From the last lecture, we could find the definition of force and its unit. Now we can move to the next topic, that is forces are due to an interaction. Some pictures are given in the textbook. Let's see. See, in the first two figures, this man is standing near the car. He just started pushing the car from the side. So in which direction the car will move? Toward this direction, because the direction of force is toward this direction. That is, the man started applying a force on the car. As a result, the car will start moving from this position, from rest to this direction. In this picture, both the girls are pushing each other. Easily, this girl is pushing up. Pushing means applying the force toward this direction, and this girl is also applying a force in this direction. In this case, both the girls are pushing each other. And next picture. See, in this picture, this girl is pulling toward this direction. That means the direction of force is toward this direction. This girl pulling toward this direction. So, forces are applied in opposite direction. In this picture, this ball is pulling toward this direction, and the cow is pulling toward this direction. From this example, we can infer that for a force to come into play, at least two objects must interact. So what we can say from these examples? Objects must interact in order to play force. Next topic, effects of forces. Before going to the topic, a person must know about state of motion and state of rest. Suppose if an object is not moving, then we can call its state will be state of rest. Rest means not moving. If an object is moving, then we can say its state will be state of motion. Is it clear? So we can move to the topic, effects of forces. Let's see what are the effects of forces. First one, what is the state of this object? This is not moving, so we can say the state of this object as rest. So if I apply a force from any point, then I can say I can move this object. So the first point is force can move an object from rest. If an object is at rest, then we can move that object by applying force. The second one is force can change the shape of the object. For example, all of you know how to make chapati. First we will mix the flour well, then after that we will make a ball. Then after pressing it on that roller, it will change the shape into a thin plate, round shape, isn't it? So actually we are applying the force in order to roll. So what we can say, force can change the shape of the object. Then the third one, if a ball is moving from that side, then I will apply a force on this side, then it will come to the rest, isn't it? So force can change force can stop a moving object also. Suppose consider this as a ball, it's moving in this direction. Suddenly I kick from this side, then it will move into a different direction. So force can also change the direction as well as speed of the object also. So these are the examples of effects of force. This is the next activity. Some of the situations are given, and in each situation how the way they are under force also given. We have to note down the diagram also given. We have to find whether the state of motion happen or changing shape also happen. The first case is the lump of dough on a plate, pressing it down with your hands. The situation is in order to make a chapati, we will make a dough, that's the first case, and in order to then pressing it down with your hands, that's the direction of force. So what will happen? Finally, shape of the dough will change. So what we can say, change in shape will be yes. Is there any change in the state of motion? That means whether we start moving from rest, first position is this place. So the dough is at rest. By pressing this one, is there any change for the position? No, it will not move from this position. So there is no change in state of motion. So we have to write no here and yes here. The second example, second situation is spring fixed to the seat of a bicycle. Then how the way you are applying the force? By sitting on the seat. So at the moment when you sit on the seat, what will happen? The spring will shrink, isn't it? The spring will compress. So a change in shape of the spring will happen. Then what we can write here? Yes, for the change in shape. Then what are the state of motion? The spring start moving, isn't it? So what we can write here? Yes, for the case of changing state of motion. In the second case, changing state of motion as well as changing shape take place. In the first case, only changing shape take place, not the changing state of motion. Next example: a rubber band suspended from a hook, or nail fixed on a wall. By hanging, weight or by pulling its force, free end. So what will happen if you hang a weight over the one of the end? It will start lengthen, isn't it? That means there is no, actually it's not moving. It was the previous position, it started moving. So what we can write? Change in state also, state of motion also happens here. Shape enlarges and thickness will reduce. So what we can write here? Shape will also change as well as state of motion also will change. The last case, a plastic or metal scale placed between the two bricks by putting a weight at the center of the scale. So scale is there. You are placing a box weight on the center. Will the scale start moving? No. There is no change in the position of the scale. That means there is no change in the state of motion. But shape of the scale will change. The reason it will start bending at the center like this. Isn't it? At the moment you place the weight, it will bend towards the center. So a change in shape is also happening. Now we can see what are the different types of forces. There are two types of forces: contact forces and non-contact forces. That means force can be classified into two categories: contact forces and non-contact forces. Then, what do you mean by contact force? I want to apply a force on this board. If I am not in contact with this board, can I apply the force? No, it's not possible. So if I want to apply the force on this board, I have to be in contact with this board, isn't it? If I am doing like this, I can apply force on this. So the forces which can only be applied when the objects are in contact with each other are known as contact forces. What will be contact force? The forces which come into play only when the objects are in contact. Such forces are known as contact forces. Examples are muscular force and friction force. The forces comes into play even without the contact between the bodies are known as non-contact forces. The examples are magnetic force, electrostatic force and gravitational force. Now we can define each and every thing. The first one is muscular force. For example, if you want to throw an object, for example I am throwing a ball. How I can throw the ball? It's due to the action of muscles. Throwing a ball, we are pushing, isn't it? So push is an example for force. So the force exerted by the action of muscles is known as muscular force. Every activity is in our daily life, because if I am beating someone, if I am hitting someone, kicking the football, all these are done by the action of muscles. The second contact force is friction force. Simply we can call friction. Consider a ball is moving in this direction. After some time, all of us know that it will come to rest, isn't it? Why it comes to rest? Because suppose the ball is moving in this direction, the floor on which the ball rolls over exert a force in the opposite direction to stop the motion of this ball. That type of force is known as friction force. Is it clear? If an object is moving over any surface, the surface will exert a force in order to stop the motion of the object. That type of force is friction force. The definition is the force which opposes the relative motion of an object is called friction. Now we can move to the example for non-contact forces. The first one is magnetic force. Magnet can attract some material. Such materials are known as magnetic materials. If you bring a magnet towards a pin or iron material, it will get attracted towards the magnet, isn't it? Because the reason is the magnet exerts a force on this material and pull it towards the magnet. That force is known as magnetic force. And the magnet can also exert a force on another magnet. If you bring a south pole of a magnet towards the north pole of another magnet, the force will be attractive because south and unlike poles attract each other. And if you bring north pole and north pole, then it will repel each other. Okay, so in all these cases, the force exerted by the magnets are known as magnetic forces. So this is the definition: the force exerted by a magnet on other magnet as well as magnetic materials is called magnetic force. Take a scale. All of us know that scale doesn't have any charges. It cannot attract any material. Just rub that scale with your hair. Then bring a small paper piece. You can make it as a bowl and try to bring the scale and paper close to each other. Then you can see that the scale will attract this charge ball, this bowl, paper bowl. The reason is when you rub scale on your hair, it gets charged. Some charges are formed on the surface of the scale. Okay, then these charges will exert a force on the paper ball. The force exerted by the charged bodies are known as static force. The definition is a charged body exerts a force on another charged body or uncharged body. This force is known as electrostatic force. The charges formed by rubbing are called static. Static means stationary. The third example for non-contact force is gravitational force. For example, I have this duster with me. Suddenly it slipped away from me. Then to which direction it will go? Directly to the center of the earth. The reason is the earth exerts a force on this duster towards the center. The direction of that force is towards the center of the earth. This is just an example. Every object in the universe, no matter whether it is small or large, can exert a force on any other object. That force is known as gravitational force. Every object in the universe, whether small or large, exerts a force on every other object. This force is known as gravitational force. The reason why the moon revolves around the earth is the gravitational force between earth and moon. Similarly, the planets are revolving around the sun is due to the gravitational force between the sun and the planets.